Okay, here we are, part 3. Now, this is where we left part 2. We've got our boat nicely moving across the water with some secondary motion. So it wobbles, it rolls and pitches a little bit. And what we want to do today is to put in the scene the effect of wind. We want the boat to roll in respect of the wind. So in this scene we have here, so the wind is blowing from here over to this way, which you can see from the waves on the ocean, and we would expect that to roll the boat in this direction. So it would come over this way because the sail's going to push it over. So when it's side on, the effect will be quite marked. And then when we come round to, say, here, we would expect the wind to push it back in this direction again, but obviously not as much because the boat is in line with the wave now and it's more stable in that direction, and it won't roll at all with the wind blowing this way. It will still roll in response to the waves, but not the constant kind of push of the wind. So that's what we're going to implement in this tutorial. It's not that difficult. We're going to use a wind vector. But I want to make a couple of changes first. So, and for now, I'm going to turn off the secondary motion of the boat. We could put it back at the end, but it's wobbling already, so it makes it harder to see what's going on. So I'm just going to turn that off. It also stops the chops from baking every few minutes. So that's taken that out. And the other thing I'm going to do is I'm going to change the curve that we're using for the path from this to this, because again it'd be easier to see what's going on, so let's wire that in. Okay, I'll move back down to the boat. So first thing we need is a wind vector, so that's just going to be a line. So I'm just going to use a line. And that's going to be in the X direction. We'll hide off the other objects for now. That's just going from left to right, and so this is the vector for the wind, so it's going from the left to the right, and the magnitude is 1. If we want the magnitude to be 2, then we just turn the length up to 2. And then it's not always going to be left to right, so we need to transform. And this number in here, say 35, whatever, that's the direction the wind will be blowing again. So we need the water, the ocean surface, to line up with that. So I'm going to copy that parameter. This is where our ocean spectrums are. So the direction of the ocean, of the waves from the ocean spectrum is there, so I'm going to paste relative reference in there. And I know, because I've done this before, that the ocean spectrum direction goes inversely to the rotation of the line, so I'm going to place a star -1 in there, and that will work fine. So Control C, and there's 2 of these, so I've got to paste that into there as well. So if I change the size of the preview grid to 150, delete channels, 150, 150. We can see that the waves are moving up towards the top right corner. Which is right, up towards the top right corner. So that's good. So we'll put that back to naught for now, because it's just going to make it easier to hook this thing up. And I'll put a null on there. So that's wind vector. So how this is going to work is we're going to find the shape that we use to control the boat, which is here. Let's get the C back up. There we go. Now this object has 4 points on it. What we want to do is to roll it, we want this point to go down and up, and this point to go down and up, and to pitch forward and backwards, we want this point to go down and up, and this point to go down and up, according to the direction of the wind. So what we're going to do is we're going to split this up into 4 vectors. We'll put another point in the middle. 1, 2, 3, 4 vectors. And we are going to dot product each of those vectors with the wind vector. A dot product is a combination of 2 vectors, and you multiply the lengths of the vectors and then do a cosine of the angle between them. That sounds a bit complicated if you're not mathematical, but you know, cosine is a mathematical function. So cosine is 1 if the angle is 0 between them. So if the wind and, say, this vector here are in line, then the dot product will be the wind vector length times this vector length times the cosine of the angle between them. If they're coincident, the angle between them is 0 and the cosine is 1. So if the wind is going this way, the angle between this vector and the wind would be 90 degrees and the cosine would be 0. So that would be naught. So if the wind's blowing this way, this point wouldn't be affected, which is what we want. And if the wind is blowing this way, then this vector and the wind vector would be pointing in exactly different directions. So the cosine of that would be cosine of 180, and that's -1. So this point would go the other direction. So it works out beautifully for what we want. So the first thing we've got to do is put a point in the middle of this shape. Okay, so at the moment we have, let's turn everything else off for now. Space G to find what we've got. Oops. Bring the points up in the point numbers. Good. So yeah, we want a point in the middle of here. So at the moment the 2 pitch points, say forwards and backwards, are 0 and 2, and the roll points are 3 and 1. So I'll make a point and merge that. In with that. And add 0.1000. There we go. So I think that's everything we need. If we go in underneath this point wrangle, go back to a camera view, good. So we're going to use a VOP now. So we want a point, VOP, that goes in there. So that goes in the first one, and the wind vector goes in the second one. And we're going to use the get attribute. And we want 3 things pulling in. So first 2 are off the first input, which is this. So we want to connect the file thing to the first input. So the first thing we want is position of all the points. Capital P? No, that's capital P. Position of all the points, and because we want all the points, we're just going to put PT num in there. And now I'm going to put a bind export in, which I was using VOPs just to check everything's working stage by stage. And we'll call the attribute it makes test data. So I'm just going to pull up the geometry spreadsheet. I'm just going to pull up the geometry spreadsheet. Like that. So we've got test data, which is, if you look, it's the same as the position, which is good. That's what we want. Okay, the next one is I want to get the position of just point 4. Point number 4, so just the middle one. So in this case, I'm going to delete that and just put 4 in there. So if I connect that to our test data, we should get the same in each column, and we do, and that's the position of point 4. Okay, next thing to do is to subtract each one of these, the position from point 4 from each one of these to give the relative positions of the points. So I'll put a subtract in. And again, connect that to our test data. So now we've got something different in all of them, and point 4 is 0, 0, 0, which is right because these are all point 4, and one of these is point 4, which is that one, and point 4 minus point 4 is 0. So that's good. Now we bring in our wind vector. So if I go back out to, oops, the wind vector here, we can see that this vector that we're interested in is position of point 1 minus position of point 0. But point 0 is at 0, so we just need the position of point 1 for that. Okay. So P, let's get that, copy that down again. So let's label these up. Positions. Point 4. Position. And wind vector. So the wind vector should be connected to input 2 over there, and the point we're interested in is point 1. So if I connect that to test data. That's good. So 0.1 is 1, 1, 1. So next thing to do is to do a dot product between these two and add that to the y component of the position. Like that. And I'm going to feed this into the y. So before we do that, we'll have to split position into x, y, z. So that's to float, and then a float to vect goes in there. Boom, boom, boom. Good. So we haven't done anything to the position yet. We want to add our dot product in there. Now, if we look at we want to add our dot product in there, and it will go crazy to start with because we need a scale factor. Yeah, like that. But let's have a look. Okay, remember the wind is blowing from left to right. It's coming down this way, so the boat is heavily tilted, and it's tilted the wrong way because it should bend away from the wind. So it's too much and it's tilting the wrong way. But that's okay. We need to flip it around and a scaling factor. So the flipping is easy. I'll just swap those two around. And the scale factor, I'm going to do a different scale factor in one direction and the other. So roll scale factor is much more susceptible to roll, so that's going to be more than the pitch. So more in this direction than in this direction. So to do that, I'm going to go back out here, create an attribute. So create attribute create. We'll call that wind scale. So we want the wind scale to be, let's say, group is 0 and 2, 0, space 2. So that's forwards and backwards. So we'll make the scale of that 0.01, and that leaves everything else to be 0.1. So 1, 3 and 4 should be, I'm told it is points, that's why. That's it now. Sorry, something wrong there. Didn't tell it was points. So 1, 3 and 4 are 0.1, and 2 and 0 are 0.01. Good, and that's wind scale. So now we go back in here and I'll copy that one up because that's almost what we want. And wind scale, and that's a float. Again, we'll test our data. Test data is the same as wind scale, so that worked. scaling factor will go in there before the add. So multiply. So multiply. And we'll just wire that into there. Not sure that's working, it's a bit hard to see. Let's turn it up a bit. 0.2, that one. 2. Yeah, that's more like it. So you can see that's working. Tell you what's not working is the ocean. The ocean stopped moving. Yeah, it's okay, it does that sometimes. See surface test, just go up to there, click around a few times, and now it will work. There you go, so it's clearly leaning away from the wind. Let's go to a different view. There we go. Beautiful. So I'm going to go back up here and I'm going to put a little mast on it so it makes it more obvious. Now, with the mast on, you can see it's a bit jiggly. That's because the springs are disconnected. So if I put the springs back on, turn the channel box back on, yeah, I think that's a bit wobbly. I'm going to turn the spring temperature up. Pitch, I'm going to put that down to 50. Put that to 1. Roll, whoops, and roll 50 and 1 again. The beauty of this is you don't need to rewind it like a solver. You can just make the changes. As long as the chops thing is baked once, you can make lots of changes. So I think a bit more damping on the roll. Maybe a bit more damping on pitch as well. Yeah, I like that. Well, that's about it for boat animation, till some more ideas congeal in my head. If you liked it, please like and subscribe. If you got stuck, please consider downloading the files off Patreon. I will very soon be doing a deluxe version of the files with guided ocean layer all set up, ready to cash out and go. So that's a turnkey solution. You just plug your whole geometry into it and press cache on several things, and you're ready to go. Thanks for watching. Bye for now.